All right, today is Tuesday the 27th. Tuesday the 27th. Okay. The agenda is on the sideboard. Today we're working on laws of exponents. I'm going to do the warm up. I'm going to go over the homework. We're going to finish the laws of exponents foldable. Did we finish the foldable yesterday?
No.
Okay, so let's finish the foldable. Okay, and then we're going to do some guided practice. Hey, sweetheart. Sit at the white table that's in the back. What's your name, baby? Okay. All right, let's write our homework down in our planner. Homework is already there. We're going to write it down in our planner. Okay. September, I erased this right here simply so I could make a copy for you all. But yesterday's date was September the 26th. So we're going to put September 26th and our goal for the week. I didn't get a chance to write this yesterday simply because I forgot. But we need a goal for this week. My goal for this week is to go over the homework by making those homework help videos. Okay. And we want to make sure that we prepare for our test on Friday. That's my goal. Your goal could be to complete your homework. Your goal could also be to make an A or B on the assessment for Friday. Okay? Something that you want to work towards for this week. Please write. Where's your planner, babe? You need one? Do you want me to give you a spare one just in case? Okay. So let's write this down in our planner. Enrique, do you have your planner? Let's write this down, babe. Jaden, where's your planner? Let's go and write our homework down. Let's turn to the next available page. And at the top, we should have written the date, 9/26 through 9/30. And this is week 5, Q1W5. Q1W5. List of things yesterday that you should have completed. Watch the video. If you didn't, don't check it off. Completed the homework. If you did, check it off. Study notes from your interactive notebook. If you did that, check it off. Okay? If you didn't, don't check it off. Now we're on Tuesday, and we're writing our homework down for Tuesday. Math 8. Watch help video. Complete homework. And study. Go back and look over real number system, rational, irrational, natural numbers, whole numbers. Go back and look over those things and how to estimate roots and order and comparing numbers, putting numbers in order from least to greatest or greatest to least. Please go back and look at those notes because those objectives or concepts are going to be on our test Friday. Okay. All right. I am available for tutoring this afternoon at 3. Is there anyone that's interested in virtual tutoring this afternoon? Okay. I just offered. If you change your mind, text me and remind. All right. Let's put our planner away. Put our planner away. Let's look at the warm-up. Raise your hand if people did not get a chance to check your homework. Is there anybody that didn't get their homework? Okay, just one person. All right, we're doing Tuesdays. Warm up. We're using order of operations to solve this numerical expression. A numerical expression, by definition, is a combination of numbers and operations. Okay? Numerical expressions do not have, do not have variables in it. Okay? They don't have variables. Okay? So let's do it. Order of operations tells us to do what first? Remember, some of you remember it as PEMDAS. Yes, baby. What'd you say? I didn't hear you. Simplify. Okay, how do I simplify? We are going to simplify, but what do I do first? Yes? Okay. All right, here we go. Make sure I'm recording. Yep. All right, so first is to do all operations within parentheses. Okay, so these brackets are considered as parentheses also. So then we go to the innermost parentheses, and there's no operation. There's no addition, subtraction, multiplication inside this parentheses, okay? So now we go to this bigger parentheses and see what we do after that. Inside the parentheses, we do the exponents first. So let's simplify the exponents. What is 4 to the second power? What's 4 times 4? 16. So we bring down the negative 3. And in the parentheses, we simplify this to 16. Plus, we have 1/2. I'm going to do this out to the side so you can see it. Times 1/2. That's the same as saying 1/2 to the second power. Multiply straight across. What's 1 times 1? 1. What's 2 times 2? 4. So 1/2 to the second power is 1/4. Okay. We still have the parentheses. So inside the parentheses, we're going to add. What is 16 plus 1/4? 16 and 1/4. Okay. And now we're going to multiply negative 3 times 16 and 1/4. A positive or a negative times a positive is going to give me a negative answer. And let's multiply 16 times the 1/4. Two ways that we could do this. We can write them both as fractions. I'm going to show you how to type them in. It's going to be super important that you do know how to type this in your calculator. Where is the negative sign in the calculator?
At the bottom.
At the bottom here, right under the 3 or beside the enter. Okay. 3. This is multiplication, so we got times. I'm going to put it in parentheses. How, Miss Reyes, do I type in this mixed number 16 and 1/4? I have my parentheses, and I'm going to type in the 16 first. Now I'm going to type in the 1/4. So that's going to be plus 1 divided by 4. Close the parentheses. This is how you type in a mixed fraction. The whole number plus the fraction. And now we're going to press enter here. And we get negative 48.75. So we got negative 48.75. Does anybody know the whole number is 40? Well, not whole number. The integer is 48. How do I write 0.75 as a fraction? 3/4. So either or is your answer. You can write it as a decimal or you can write it as a mixed fraction. I'm going to pause for the calls to give us a chance to write that. You want me to do one before you go to the restroom, just in case those, you know what I mean?
Yeah.
Which one, Monday?
Yes.
Okay.
I think the last one on the teacher one was really confusing for them, and
Okay.
then the first one on the other one.
Okay. All right. And I think I did the last one in the video. I didn't?
No.
Which one did I do?
You did the
1 and 2.
you did 1 and 2 on the teacher model, and then you did one on you try.
Oh, you know why? Because these are addition and this one's subtraction. And I realized after the fact that I did all addition and no subtraction. That's why I did that. Does that make sense?
Yeah.
All right. Okay. All right, so let's look at number, which one you say, 3? This one?
Yeah, 3 and 1.
So you have to apply the same rules as we did with the others and find a common denominator. I'm going to write it vertically. Okay, so I'm going to do 13 over 7, and I'm going to do 3 over 2. Okay, I'm going to find a common denominator for both. To find a common denominator, let me put my plus sign here. To find a common denominator, I'm going to write the multiples for the largest number. Which number is bigger, 7 or 2? Which number is bigger, 7 or 2?
7.
So I'm going to list the multiples for 7. The first multiple for 7, that means 7 times 1 is 7. Okay, 2 will not go into 7 evenly without a remainder, so I'm going to keep listing my multiples. My second multiple, that means 2 times 7 is what? 14. Okay, will 2 go into 14 without a remainder? Crickets. Will 2 will 2 go into 14? Leah, sit up, babe. You okay? You sure? Okay. Will 2 go into 14 without a remainder? How many times will 2 go into 14? It will go 7 times. So we're going to use 14 as our common denominator. Okay?
Oh, light bulb just went off in my head. I get it now.
Yeah, it's all good. So what number can we multiply times 7 to give us 14? 2. So to make an equivalent fraction, whatever we multiply the bottom by, or the denominator, we also must do to the numerator. So we're going to multiply 13 times 2. You have your calculator. Type that in if you don't know. What is 13 times 2? 26. Okay. Now let's look at the bottom. To make an equivalent fraction here, think. What can we multiply times 2 to give us this 14? 7. So to make an equivalent fraction, we also have to multiply the top number, or the numerator, by 7 as well. What's 3 times 7? 21. Okay, so now we have common denominators. So our denominator stays the same, and we're adding, so we add our numerators. That gives us 40 what? 47. And you can leave it as an improper fraction, or you could change it into a mixed number. Okay, it's okay to leave it as an improper fraction, as long as the improper fraction is reduced. Any questions, comments, or concerns? Are there any others that you need to see?
Y'all want to see number 1?
Do you need
The
to see
subtraction?
number 1? Okay, and I did do that one. All right, this one or this on this side?
Yeah,
This one, the subtraction one. Okay, and if you have to go to the restroom, we need to do that now. Okay, and I'm going to work on the homework. Okay. All right, so let's subtract. When you subtract fractions, we have common denominator. We have to find a common denominator. So we take the highest number is 8, and list the multiples for 8. 8 times 1 is 8. Okay. Will 7 go into 8? No, not without a remainder. 8 times 2 is what? 16. 7 won't go into 16 without a remainder, so let's keep going. What's 8 times 3? 24. And it won't go into 24 either without a remainder. What's 8 times 4? 32. It won't go into 32 evenly. What's 8 times 5? 40. That won't go. 8 times 6? 48. 8 times 7? 56. That's the one it'll work for, 56. Okay. What number can I multiply times 8 to give me 56? I just did it. 7. So I multiply the top by 7. What's 5 times 7? 35. Okay. What can I multiply 7 times here to give me 56? Not 7, that's not right. 8. So we're going to multiply the top by 8 also. So that gives me 8. So now I can subtract. My denominators are the same. Keep the same denominator. And now let's subtract our numerators. What's 35 minus 8? Use your calc. So 35 minus 8? What? So let's reduce this fraction, okay? We can divide both the top and the bottom by what number to reduce it? Okay, let's type it in then. Type in 27 divided by 56. Guys, do y'all have a question back there? Shh, whisper. That is not a whisper. You are loud. I can hear you all the way up here. Math, enter. And that, well, it's already reduced. Okay, so we keep it just like that. All right, do y'all need to see anything else? Colton? Do y'all need to see anything from Tuesday? Okay, this first one, I'll do this one over here. We're going to add the numbers, the whole numbers together, because you see how we have common denominators, so this is going to be easy. So let's add the whole numbers. What is 8 plus, or I can write it like this actually. And we can deal with the fractions first. The denominators are the same. Add your numerators. What does that give you? Add your numerators. What does that give you? Oh, Lord. Sorry, what'd you say, babe? 2. Thank you, Ashley. Okay. Add your whole numbers. What does that give you? Say again, baby. What's 2 over 2? What's 2 over 2? 1. So we're going to say 15 plus this 1, and that gives you what? What does that give you? 16. Okay. We're going to do the same thing for this one right here. We got 1 and 7 over 9 plus 2 and 1/9. Okay. The denominators are the same. Add your numerators. What's 7 plus 1? 8. Now add your whole numbers. What does that give you? 3. There you go. Okay. For this one, you have to have a common denominator. What's going to be the common denominator for these two fractions? What's going to be the common denominator for the two fractions here? 3 and 8. What can be my common denominator? What's my common denominator between 3 and 8? Yes. 24. Good job, babe. What can I multiply times 3 to give me 24? 8. So I multiply the top by 8. What's 2 times 8? 16. Okay. Here, the bottom. What can I multiply times 8 to give me 24? 3. So I multiply the top by 3. What's 3 times 3? 9. So I'm subtracting. What is the denominator? Sorry. Denominator is the same. Let's subtract. What's 16 minus 9? Use your fingers and your toes. Yes, it's 7. Okay. Yes, baby. I can. You got it?
Not written down yet.
Okay. Do you see it though, babe? Okay. All right, and I'll pause for the calls. Let's go ahead and put this in our folder. Let's take out the foldable on laws of exponents from yesterday, please. so we can finish the foldable and paste it in our notebooks. Okay, I'm going to recap the ones that we did yesterday. I'm going to go over those again, make sure we have it right, and then we're going to do some guided practice problems. All right, I'm going to pause. Anybody not have this foldable, please raise your hand so I can get you one. All right, here we go. Okay, so when you are multiplying exponents that have like bases, you add the exponents. Okay, you add the exponents. In the example, this is telling you x is being multiplied 5 times here, x is being multiplied 7 times here. So x is being multiplied a total of 12 times. Let's look at the second example. G is being multiplied 2 times here. G is being multiplied 4 times here. How many times total is G being multiplied? 2 plus 4. G is being multiplied a total of 6 times. Dividing. When you are dividing, you subtract the exponents. Okay? On the top, you have x being multiplied 7 times. On the bottom, you have x being multiplied a total of 3 times. When you cancel it out, when you cancel the x's out, you are left with 4 x's. The shortcut way, thank you. The shortcut way to find your answer is to subtract top exponent minus bottom exponent. So that's x to the 4th power. Okay, again, P, the bases are the same. The base is P. You're going to subtract the top exponent minus the bottom exponent. That is 8 minus 5. So your answer here is P to the 3rd. The last one, top exponent minus bottom exponent. That's 9 minus 3. Your answer is V to the 6th power. Okay. An exponent raised to another exponent. Do you have one of these, babe? Or do you need one? Okay. You're going to multiply the exponents. So here, whatever this exponent is times the outer exponent. So in my example, 2 times 3 is 6. So this is x to the 6th power. In number 2, inner exponent times its outer exponent. 7 times 4. 7 times 4 is 28. The last one, multiply the exponents. 5 times 2. 5 times 2 is 10. All right. This is where we left off on yesterday. We have an exponent that is negative. You write it as a fraction. And I'm going to show you why. I didn't get a chance to show you why yesterday. All we did was write down the rule and did an example. But now I need to show you why this works. Okay. All right, I'm going to show you this one more example or these 2 examples, and I'm going to show you why it works. You're always going to write this when you have an exponent that is a negative. If the exponent base is on top of the fraction, move it to the bottom to make it positive. If it's on the bottom of a fraction, move it to the top to make it positive. So here, this is on top of a fraction. So you have your numerator is 1, and you push it down to the bottom of a fraction, and now it's positive 2. Same thing here. This is a whole, well, actually, this is on top of the fraction. You would normally write it just like this. So to make it a positive exponent, move it to the bottom of the fraction. So it's going to be 1 over a now to the positive 7. Okay, please write that down, and then I'm going to show you why that works. Okay, this is how this works. I'm going to give you an example. All you're doing is just watching so you can see why and what we're doing is going to give you the correct answer. All right, so let's suppose that let's choose a small number. Let's choose 2 to the 3rd power divided by 2 to the 5th power. The bases are the same here, okay? So we can apply these laws of exponents. Again, we have 2 to the 3rd power and then 2 to the 5th power. So when we simplify this, let's look at the numerator. 2 to the 3rd power we write in expanded or exponential form as 2 times 2 times 2. Any questions about that? 2 to the 5th power, rewrite as 2 times 2 times 2 times 2 times 2. 1, 2, 3, 4, 5 times. Any questions about how to write this in expanded form or exponential form? Kate, sit up. So now we divide. What's 2 divided by 2? 1. What's 2 divided by 2? 1. What's 2 divided by 2? 1. So on the top, we have 1 times 1 times 1. What's 1 times 1 times 1? 1. Okay? And here, what is 2 times 2? 2 is being multiplied how many times? Twice. This is how I write this answer in exponent form. If I was to do this the shortcut way, I would subtract these exponents from each other. I would say my bases are the same, and I'm going to rewrite here. The bases are the same, and I subtract top exponent minus bottom exponent. That's going to be 3 minus 5. What is 3 minus 5? What's 3 minus 5? I think somebody said it. Negative 2. Which is the same as this here. You write this. Anytime you see a negative exponent, you're going to write it as a fraction. 1 is your numerator, and you push this down to the bottom to make it positive. Any questions about that? When you have a negative exponent, it's telling you that your answer looks like this. Okay? So anytime you see a negative exponent, you write it as a fraction. Oh. Got it? All right, let's do one more. 4. Let's do 4 to the 5th power. And then let's do 4 to the 7th power. All right. How many times do I write 4? 4 to the 5th power, I multiplied how many times? 5. 1, 2, 3, 4, 5. How many times do I write 4 to the 7th power? How many times do I multiply it times itself? 7. 1, 2, 3, 4, 5, 6. One more time. Miss Reyes. All right, what's 4 divided by 4? It's 1. What about here? 1. What about here? 1. What about here? What about here? So on the top, 1 times 1 times 1 times 1 times 1 is what? It's 1. On the bottom, what's left? 4 to the what power? 2nd. All right. Any questions? Shortcut is telling you to subtract top exponent minus bottom exponent. So that's 5 minus 7. What's 5 minus 7? Negative 2. So we write this as this. 1 over 4 to the positive 2. That's how we make it positive. All right, let's keep it moving. All right, let's do this one. If we have more than one term in the parentheses, sorry, y'all. If we have a product of a power of a product, is how they say that. Okay. A power of a product, which means that there's multiplication in the parentheses. All we're doing here is distributive property. So the rule here is distributive property. If you don't see an exponent on a number, what do you think the exponents automatically are if you don't see an exponent? Anybody know? Take a guess. Say it out loud. 1. Very good. So we're going to multiply whatever number this is here times both the numbers in the parentheses. So we got 1 times whatever the number is. We got 1 times whatever that exponent is here. All right, so let's go and do some examples here. We have x is automatically a 1 as an exponent. So we got 1 times 3. We have y. 1 is automatically the exponent here. So we have 1 times 3. So our final answer is going to be x to the what power? Third power. Good job, Abby. Y to what power? Third power. And then let's circle that. Let's do the next one. What exponent is automatically there if you don't see it? It's 1. So we got 1 here and 1 here. We're going to distribute. We're going to multiply the 5 times all the exponents in the parentheses. So this is going to be J 1 times 5. K 1 times 5. So what's our answer here? J to the what power? Fifth. K to the what power? Fifth. See if you can do number 3 on your own. Okay, 0. 0 exponent is just saying that you're not going to multiply that number at all. So your answer is just going to be 1. Any number that's raised to the 0 power is just going to be 1. X raised to the 0 power is 1. F raised to the 0 power is 1. 100 raised to the 0 power is 1. W raised to the 0 power is 1. Any number raised to the 0 power is going to be 1. Because all it's saying is you're not going to multiply that at all. Ms. Reyes, why is it that it's not going to be 0 then if you're not multiplying it at all? And that's a great question. Look, if you have 5 to the 6th power times 5 to the 0 power, this is just saying don't multiply this at all. Look at what happens. If I multiply this by 1, then my answer is still going to be 5 to the 6th. Okay, which means I've actually multiplied 5 to the 6th. Okay, but if I make that 0, then guess what happens? It makes the whole answer 0. This is what we don't do because it's still telling us to multiply 5 times itself 6 times, but just don't multiply this 5 at all. And that's what we did. Okay, if you make it 0, then that makes your whole answer 0. Okay, so any number raised to the 0 power is going to be 1, not 0. Okay, all right. Your whiteboard, please put your whiteboard in front of you. And you have a marker. All right, so let's write 2 to the 3rd power. Label the 3 and label the 2 and hold it up so I can see it. I need you to label the 3 and label the 2. Hold it up so I can see that you labeled it correctly. Make it big so I can see it. Label it. Don't just put the arrows. I need you to put what is this 3 in this relationship? What is this 2 in this relationship? Don't say anything. Just write what you think and hold it up. All right, so this right here is the exponent. And this right here is the base. Okay, now write the definition for exponent and write the definition for base and hold it up so I can see it. That's okay. All right, exponent. Somebody got that one right. Okay, I saw one person that had that one right. The exponent, and it was Abby, tells you how many times to multiply the base. Tells you how many times to multiply the base. Okay, then what's the base? What's the definition for base? We wrote this in our notebook. It's not the starting number. The number getting multiplied. The number being multiplied. Very good, babe. The number being... Yes, babe. Thank you for telling me. Okay. All right, there's a little half sheet that's on your desk. You can... Sorry, y'all. When you're rushing, that's how those type of things happen. And I try to rush to get everything in. Sometimes I make it, sometimes I don't. Write your first and last name on this little half slip. And I want you to put which one of those numbers is the base and which one of those numbers is the exponent. You need one. Raise your hand if you didn't get one. I'm sorry, y'all. Sorry, baby. Anybody else not get one? Okay, I'm going to call on you real quick so you can tell me what the answer is. All right, base. Number 1, Carter. W is the base. What's the exponent? -9 is the exponent. Number 2, America. Which one's the base? G is the base. What's the exponent? 3 is the exponent. Number 3, Jaden. Base is H. What's the exponent? -5. Very good. Number 4, Samantha. S is the base. 6 is the exponent. Number 5, Hayden. Z is the base. Excellent. Number 6, Atiana. Mm-hmm. Very good. Number 7, Kason. Mm-hmm. Very good. Number 8, Arturo.
The base is R and the exponent is -3.
Very good. Number 9, Ashley. -4. Very good. Number 10, Haley. V is which one? Base or exponent? Base. -6 is what? Exponent. Okay. Number 11, Aaliyah. Very good, sweetheart. Kate, number 12. Very good. Julian, number 13. 13, baby. This is L and this is 8. Very good, sweetheart. 14, Enrique. 14. Mm-hmm. Great job. All right, let's go ahead and put this in our folder, please. Work to do. And put your calculators back.